Welcome, friend. If you've ever stared at a circuit board and wondered, what exactly are those tiny, brightly striped little cylinders, well, you are in the exact right place. Today, we're going through a friendly, absolutely foolproof explainer designed to completely demystify resistor color codes for complete beginners. Seriously, by the time we wrap up, you'll be reading these essential electronic components like an absolute pro. And the best part? No complicated math required.
So here's our game plan for today. First, we'll be decoding the tiny rainbow. Then we'll look at the color code table. After that, we'll read some 4-band resistors, level up to reading 5-band resistors, and finally, let's practice together.
All right, Section 1, Decoding the Tiny Rainbow. Why even use color codes in the first place? Take a look at this beautiful visual guide by Technomaster. This is going to be our master blueprint for this entire explainer. Now, look at those real components in the background. Electronic resistors are physically tiny. I mean, they are simply way too small to print long strings of numbers on in any way that human eyes can actually read, especially once they're soldered flat against a circuit board. So engineers came up with this brilliant workaround, a clever rainbow code. The colored stripes wrap all the way around the cylinder. That means you can read a resistor's value no matter which way it gets installed. Pretty smart, right?
Moving right along to Section 2, the color code table. Let's crack this code.
This foundational system is beautifully simple. Let's just focus purely on the base digits first. It's basically like a decoder ring. Every color on a resistor simply represents a single number, from 0 to 9. That's it. Black is 0, brown is 1, red is 2, orange is 3, all the way up to white, which is 9. That is the core language right there. You're just translating a color into a single digit. Okay, so once you have your base digits, you'll hit a band called the multiplier. And look, I want to bust the jargon right here. Multiplier sounds like you're going to have to do complex math in your head, but you don't. In pure, simple English, the multiplier is literally just the number of zeros you add to the end of your base digits. Seriously. If the multiplier color translates to a 2, you just add 2 zeros. If it translates to a 4, you add 4 zeros. It really is that simple. Finally, you're going to notice one band sitting slightly apart from the others over on the right side. That is the tolerance band. Now, because real-world manufacturing isn't absolutely perfect, the tolerance just tells us how close the actual real-world resistance of that component is to the perfect value we calculated. So a gold band, for example, means the resistor is guaranteed to be within plus or minus 5% of its stated value. Think of it as essentially the manufacturer's margin of error. All right, Section 3, Reading 4-band resistors. Let's look at some standard resistors. Let's actually read a standard 4-band resistor. We'll focus on the blue-bodied one, labeled 10K, right at the top of our guide. We just follow 4 easy steps, reading the bands from left to right. Step 1, find the first digit from the first band. Step 2, find the second digit from the second band. Step 3, look at the third band to apply that multiplier, and remember, that just means adding zeros. And Step 4, check that final metallic band on the right to get your tolerance. Let's map this directly onto our blue example. The very first band is brown. Checking our table, brown equals 1, so our first digit is a 1. The second band is black. Black equals 0, so our second digit is a 0. Right now, we have the number 10. Awesome. Our third band is yellow. Yellow means 4, so our multiplier is 10 to the power of 4, which just means we simply add 4 zeros to our 10. Finally, our fourth band, sitting by itself, is gold, giving us a tolerance of plus or minus 5%.
Putting it all together, what do we have? We have a 1, a 0, and then 4 more zeros. That gives us 10,000 ohms. Now, in electronics, we often use the letter K to stand for thousands. So a 10,000 ohm resistor is commonly just called a 10K resistor. Look at that. You just cracked your very first combination lock.
Next up, Section 4, Reading 5-band resistors, adding a bit more precision.
For this one, let's use the green 33K300 resistor from our guide as the example. And hey, don't let that extra stripe intimidate you. If you visually compare a 4-band to a 5-band resistor, you'll see they are functionally almost identical. A 4-band resistor has 2-digit bands before the multiplier. A 5-band resistor simply adds a 3rd-digit band before you hit the multiplier. Literally, that's the only difference. It just allows for a more precise, specific number.
Let's trace the steps for our green 33K300 example. The first band is orange, which gives us a 3. The second band is orange, which is another 3. The third band is orange again, so you guessed it, another 3. So our base digits give us 333. Now the fourth band is our multiplier, and here it is red. Red equals 2, meaning we simply add 2 zeros. Finally, that fifth band all the way on the right is brown. According to our table, a brown tolerance band indicates a very strict margin of error of just 1%.
Let's combine them all together. We take our base digits of 333, and we tack on those 2 zeros from our red multiplier band. That gives us exactly 33,300 ohms. See? It's the exact same logic as before, just with one extra digit in the front. You've totally got this.
And finally, Section 5. Let's practice together. Time for a quick skills check.
Let's see how this logic applies to 3 common everyday examples. First, look at the 150 ohm resistor. Brown is 1, green is 5, and brown is a multiplier means we add 1 zero. That gives us 150 or 150. Boom! Next, the 3300 ohm resistor has orange, orange, red. That's a 3, and we add 2 zeros for 3300. Easy! And how about the 4700 ohm resistor? Well, yellow is 4, violet is 7, and red means add 2 zeros. Boom! 4700 ohms. Notice how all of these have a gold final band, meaning a standard 5% tolerance. They all perfectly follow the exact same beautiful logic we just learned.
Now, you might also encounter some fun edge cases out there in the wild on a real circuit board. Our source guide shows us tiny values, like the 47 ohm resistor, where a black multiplier band actually means add 0 zeros. You just leave the digits as they are. There are also the 1.2 ohm and 0.33 ohm resistors that use gold and silver as multipliers to actually move the decimal point backward. But honestly, the absolute coolest one is sitting right there at the bottom right. It's called a jumper. It has a single solid black band. Since black is 0, this component literally has 0 ohms of resistance. It's simply a wire bridging a gap on a circuit board, cleverly disguised as a resistor.
You know what? You've done it. You have completely demystified the resistor color code. You know how the table works, you know how to combine base digits with multipliers, and you know exactly how to spot the tolerance. You are no longer in the dark when you look at a circuit board. So I'm going to leave you with this final exciting thought. Now that you can decode the rainbow, what will you build next? Grab a breadboard, gather up some components, and just start creating. Thank you so much for joining me on this explainer, and happy building!